we apologize for this delay. It's a technical delay here. And my name is Natalia Panovich. I'm a lecturer in the School of in the School of Landscape Architecture and Planning. And this is a CAPLA's lecture series. And today we have Professor Bryan Heidorn with us. And you already have his bio on the website, so I don't want to waste our precious time. I want to go straight to Bryan's presentation. So thank you for being here today. Thank you to our audience who's here with us in person and to everybody who's online. We're going to hold off to have our questions till the very end. You can also put them in the chat and we'll just answer them at the very end. So with this, Bryan, please take it away.
Maybe I should do power too. We'll see if my battery pulls out. Yeah, if you can get power there, that would be great. Okay, so I'm going to do a general high-level overview of AI, and with a particular emphasis on education. And so I'm going to start with an introduction of me. I'm the Associate Dean for Research at the College of Information Science, which is just across the parking lot from you in Harville, mostly, although a couple other places on campus where we've overgrown our space. So I did my dissertation with AI back in 1997, was natural language processing and synthetic image generation. But that was a rule-based system. And I'll tell you why I did that. That's not the current popular method, although rule-based systems still exist. But I was trying to do human modeling at the time. And this is just some research projects that I've been involved in recently, so I don't have to get into that very much. Mostly I work in biology sort of areas. So some of the main points I want to make is, in the first part of the talk, is what is AI versus machine learning, do a definition of that, talk about perceptrons, deep learning, and then generative AI. And then I move into how that relates to education overall. So I started off by asking ChatGPT to answer that question. So I asked it what's the relationship between machine learning and AI. So I used ChatGPT 5, so the latest release of that. So they're closely related and not the same. So I agreed with what the system said. And then artificial intelligence is a field of computer science, although I would say it's also psychology, and some other fields play critical parts. So I disagree with the definition in a little bit, but it is a central issue for computer science, particularly for efficiency things. To perform tasks that normally require human intelligence. So AI has to be what a human would normally do. And some of those areas are reasoning, problem solving, understanding language, and perception. I'd say that AI was wrong a little bit in that when it talked about machine learning, it said it was a subset of AI. But there's certainly machine learning methods that are not meant to simulate human intelligence in any way. They're just learning methods, more like statistics, cluster analysis and things like that we wouldn't call human intelligence. And humans actually do some of those tasks really, really poorly. So, but machine learning does it really, really well. So it's not a simulation at all of AI. So I would say machine learning is distinct, well, related to AI. Machine learning is the dominant model for doing AI now, but there's ways to do AI that's not machine learning. And likewise, within machine learning, there are tasks that are being performed that are not AI, that are just processing. It's like statistics and mathematics, but very useful things to do. And instead of programming, the distinction is instead of programming a solution, you have the system learn a solution by looking at data. So just so that we have some vocabulary. This is also from ChatGPT continued, and I'll critique it as we go and explain why I think that's a useful approach. So AI is a goal of building intelligent systems, and I agree with that. That's the objective for doing AI. Machine learning is one of the main tools to achieve the goal. I agree with that as well. So notice it changed its mind a little bit and said a main tool as opposed to all the tools for doing it. So examples they have AI applications would be speech recognition, like Siri and Alexa. And then we have machine learning examples there related to language, which is appropriate because it gave examples of Siri and Alexa, since they're language oriented mostly. So I said I would talk about the roots of some of this. 1969, I was doing a master's degree and left and started a software company and then went back and got my PhD. But when I was working on my first models for natural language processing, I wanted to use neural networks and deep learning because I was very interested in human brain architecture and how humans do language. And I had worked in a biometrics lab doing, studying how humans process information. But my dissertation advisor said I couldn't because Marvin Minsky and Popper published a book called Perceptrons and proved that neural networks won't work or perceptrons won't work. And therefore I wasn't allowed to do my dissertation using neural networks. That book was followed by an AI winter. A lot of the research that had started before the writing of that book, the money dried up and AI went away for a little while until somebody started making deep neural networks and discovered, including Hinton, who you may know about, who was at Google recently and retired. All that, so you may have seen him in the news. But he kept the religion and kept doing the deep neural networks and eventually was having breakthroughs. So what's so hot in AI now over the last 4 or 5 years that the general public got attention is these deep neural networks. A perceptron is only one layer deep. A neural network is simple decision units that are simply taking input, so this is the input layer. So stimulus like words might go in this level. And then there's multiple hidden layers, 2, 3, or 4, 5, and then an output layer where you want the results to come. And you could do early, in the 1970s, people discovered backprop, an easy learning mechanism where you can feed to the network.
Hello?
Here.
Hello?
I can feed that neural back to the network. And the
We
network
can't hear when you walk away from the computer.
and then tries again. And you do that over and over and over again.
I don't think they can.
Oh, no, I need a microphone. We're using a computer that's not the one, not the one I wanted.
Yeah, if you could just stay closer to the screen, we can hear you better.
Yeah, okay. I also have trouble hearing you, but that's okay. All right, so we have neural network. These are deep neural networks, and LLMs, large language models, are built on these multi-layer networks. And the perceptron mathematical proof that it won't work was only working with a single layer network. And once you get into multiple layers, the restrictions like being able to do an XOR logic decision, turns out you can do it if you have multiple layers in your network. So the reason that AI is taking so much power partly is because these neural networks, you'll hear people say things like they're trying to make, there's a new project coming out of the Department of Energy called the Trillion Parameter Initiative or something like that, trying to be able to have a trillion of those little dots to do the calculations, to solve bigger and bigger problems. All right, so there's another class of machine learning and AI I want to talk about. Generative AI is a term you may have heard about as well, and it's a subclass of AI and machine learning techniques where the objective is to create a system where that output layer is generating an object that humans would normally produce. That might be language, So if you're using ChatGPT, that's using a large language. It's a form of generative AI, which uses a large amount of data input to train it in order to produce output that would be what humans would produce or to generate words. But then there are like DALL-E and some other tools do images. They're generative AI as well. Their input for training is images and their output for training is images as well. My dissertation was having text as input and images as output, but that's a whole other story. We won't go into that, how we did that. So generative AI can be images, video, music, text, any of those things. They all require vast amounts of data for learning. And what that's led to is, at its extreme, ecological problems around the world, because the amount of energy and water that's needed to run the data centers is so great. One of the reasons that Project Blue here in Tucson has been so controversial is to build a data center is going to use a lot of water and energy. So it looked like human energy consumption from fossil fuels was starting to go down, and now it's climbing again, largely driven by AI and this need to suck in large amounts of data and then to be able to process that data through all those nodes in the multi-layer network. And we don't have to go in. I just have some examples of different flavors of generative AI, and people can ask me other questions about that as we go on. So generative AI is the subtype of AI that led to ChatGPT, and it's a subset of machine learning techniques that is centered around deep learning models with many layers of many layer neural networks. The general architecture for a large language model, that's a generative model where text is the input, is you have, well, actually for all of them, this sort of works. You have data collection, pre-training, fine-tuning, which is optional, and then deployment of the system. So when you start with a large data collection, like everything on the internet, there's a bunch of garbage out there. And you get garbage in, garbage out. You get racial bias and all kinds of nasty other things that are out on the internet. You can fine-tune the system by feeding it auxiliary data or reiterating the data you had before to try to clean up some of the problems that happen with the data that you were feeding it in. So now there's an active area of research going on, is how do we fix the data? Not the algorithm itself, the AI algorithm, but how do we fix data? So there's a lot of people working in that area in fixing and cleaning data, making data machine readable, or making data AI ready. So over the next couple of years, you'll start hearing that, because much of the human knowledge is now represented in all the language stuff is available on the internet. They could import it, but we have a lot of other information that's in numerical format and spreadsheets and a large variety of data formats that are not accessible by computer now. So there's initiatives to try to figure out how do we feed the beast? How do we structure that data so that it can be absorbed? So you'll be hearing a lot more about that as time goes by for legal issues and all of that. This was generated by ChatGPT. This is a ChatGPT generated image of what the steps are. And it left out, I would say, we should have added to that filters at the end. So in addition to fine tuning, because there are hallucinations and machines that will recommend that people commit suicide and things like that, there's an effort to build filters at the very end to watch what's coming out of the large language models and filter out bad stuff before they let the humans consume it. So there's a lot of work, sometimes using machine learning again, to do a filter after the large language model or after any of the generative AI to prevent the hallucinations and biases and other things that are coming out of the systems right now. So that's an active area of work, and it doesn't work all the time. One of the things I wanted to point out first was, will AI take our jobs? And the answer is, hell yeah, it is. And I have some evidence examples from that. So this is from the Federal Reserve Bank of St. Louis the spring or February, spring in Arizona, still winter other places. Impacts of generative AI on work productivity. And we see that some areas there's very little input. I wish I could see on my screen. I had to walk over here. I guess the important point is information services are being used the most, and they're leading to the most productivity gains as a field of study. So those of us that are information workers, consider ourselves information workers, are sort of dead-eye in the center of disruption of what's going to happen first, or is already happening now. And on the bottom left, we have leisure accommodations and some other subfields, manufacturing. So those are not being impacted by the current generative AI flow. There are productivity changes happening, but not as extreme. So this kind of chart is why it is that us in academia that mostly are word and number pushers are in the crosshairs. And the students that we graduate often are also in the crosshairs because of that, because we're knowledge workers and knowledge is what's being encoded right now. And this is just how the data was collected. The productivity gains for this, the data was collected in November of last year, and it's changing very quickly, but it's relatively modest gains. So on a 40-hour work week, a savings of 5% or so, which wouldn't seem at that transformative all by itself, but and 1.4% overall for all workers. So it's not that big of a gain, but AI hasn't rolled out in most places yet. So if you look where AI has been implemented and used a great deal, you get a very different picture from what the Fed had. So the visual capitalist is just presenting some data. I'm saying where the data comes from here, if you want to look at it later. Go ahead. So productivity gains we have here. Writing tasks go from an 80-minute writing task is reduced to about 25 minutes or 20 minutes. So you're getting a 4-fold or 5-fold increase in productivity for that kind of an operation, doing semi-original writing. Active learning has a relatively large impact. So you're seeing here, quadrupling, doubling, tripling of productivity coming out of these particular activities when people use AI effectively. I want to point out why current AI sucks a little bit before I go to it taking over the world. AI makes mistakes. This particular kind of AI is non-deterministic. We don't understand what's going on in those deep neural networks. It's an active area of research to try to understand what's going on. It's a black box. And because it's a black box, we can't control the outputs 100%. And it makes mistakes, and we can't just go in and fix the nodes that are wrong to fix the mistake. It turns out to be really difficult to perturb the network and get it to behave the way you want it to behave. So mistakes persist. It hallucinates because many of them are reflective. It looks at its own output and remembers the prior discussions. It tries to keep coherence in its discussion, and that can lead to hallucinations. Once it makes a mistake, it'll build on its own mistake and build up a fake world, which produces consistency for its output. And we've come to call that hallucinating. Another problem is the high energy cost I already brought up. Getting all the data in, managing the data, and then processing the data through the multi-layer network. With GPUs, for example, it's really hard to get your hands on GPUs now. The university research computing had a lot of trouble buying GPUs because they're being sucked up by industry to run these big models. They're originally designed for the game industry, but it turns out little processors that run in parallel is the best way to do this. New architectures are coming along to solve that. But you have these tens of thousands of GPUs. Each one can have thousands of processing. Each board has thousands, and you're putting thousands of boards together. There's unproven productivity gains. So overall, some companies have failed miserably, and I'm going to point out why, some of the reasons why, in showing productivity gains after adopting AI. Excessive use of power, it's redundant with the higher one. These are mine, not AI's that I listed here. We have social issues of concentration of wealth. Whoever owns the source of production, that's sort of Marxist, whoever owns the source of production accumulates the capital. So just a few people own these big processing systems. So it's Bezos owning Amazon and the computing network that's behind it. So either the corporations or the individuals running that. And so wealth tends to accumulate to those owners. And the other thing that might suck later is artificial general intelligence, which everyone is pushing for right now. So that's a form of these generative models, or it could be any other model too, but probably will be the first one will be this generative model that outperforms humans. So superhuman intelligence or superhuman intelligence. And the theory is once it breaks the barrier, it's sometimes called the singularity. At a certain point, the systems will become self-aware and be able to reflectively improve their own operations. And we won't be needed in order for the AI systems to improve their own operations. And at that point, it can go exponential, the AI growth, because it'll be AI building AI. And then we're into the Skynet scenario, if anyone has watched the Terminator series, where it is really sentience. So that's what they're talking about. When it actually gets to that point, I used to think that it was still 10 or 20 years off. Actually, for the last 20 years, I thought it was 10 or 20 years off. And now I'm thinking maybe it actually is only 5 years off. 5 years off. It could only be 2 years off, maybe, before we get to AGI. And that could be a very good scenario or a very bad scenario, depending on what restraints we put on the system. And one of the reasons I have that belief is the current investment will lead to new products. Money is pouring in at a very great rate to the development of these AI systems. There are great promise for productivity, enough that it's attracting hundreds of billions of dollars at a time, pouring into developing new methods and rolling out the infrastructure. And I believe some of that'll be wasted, but some of it will lead to quick improvements in these AI systems. So while they hallucinate now, they make mistakes now, they consume a lot of energy now, all of those issues are being addressed with all this money coming in. And I expect we will get many much better systems, or much more effective systems. I don't know about better, but much more effective systems coming out at a pretty great rate. So we can expect new models, that those tuned neural networks, deep networks, there'll be new ones that come out. If you work in this area, you can go to the shelf and pull pre-programmed neural networks off and use them as a starting point to build your own systems now. And they're free, some of them are freely available, Llama, and some others you can just grab and build off of and do the fine tuning yourself. But the main models are available. But those will get bigger, easier to train, have new data types integrated with them. Some of them are now behind paywalls, and that's the accumulation of wealth. The owner of it is going to accrue the benefit of the productivity. And some of them are in the open. And I think that's a major role for universities. Universities can be an equalizer, and learning and making sure there's always open systems to build on, and too much of it doesn't become proprietary and not accessible. But that's a whole other talk. There'll be new machine learning ready data formats available to get new data in. There'll be new hardware to get beyond the GPU bottlenecks that we have right now. There'll be new data centers built and new applications, new products built that'll help spur even further development. So all of these things are feedback loops, lead to feedback loops. And there are, of course, social consequences to this. What does a company do with its workers if it has a fourfold increase in productivity? They can either increase products at that level if there's a market, but if there's not a market for their product, and I just said the information products are the ones being hit first. If there's not a market for it, then they're probably going to get rid of workers. So people like traditional programmers will probably be among the first to be disrupted and maybe be displaced. Except there's such a backlog of all the software we could make that would be useful that maybe there'll be a buffer and some time for people to adapt. The current model is for human programmers to pair with AI and work together to get to a solution. But as the systems improve, the human's role in the loop will probably decrease over time. So what happens to education when virtually all students use AI? The majority of students here at the University of Arizona, there was this informal survey done a couple of years ago, and I wish I could remember who did it. They were reporting to the Associate Deans for Research. Something like 90% of students say they use AI to do their work at the university. Not for every class, but they use it. And there was a study. So out of Forbes, it's just a few days ago, came out that 90% higher education fluency support. So it's already happening. The students use it whether you use it or not in your classroom. After graduation, the students will continue to use it because the corporations expect to use it. And that means it's really our obligation to absorb AI and get them ready for that marketplace. If we're not using AI in our classrooms and using it as a production tool for them to understand what they're doing, we're not doing the students a service for the related to the job market that they're going to be entering. Another social consequence is uncovering bullshit jobs. There's a book, I think that's my next slide. I'm not able to see ahead here. Oh yeah, there was a book, David Gruber, called Bullshit Jobs Theory, that a lot of what happens in our organization now is the production of reports and PowerPoint slides and other things that don't actually lead to higher productivity for the corporation. And then as AI is hit, it's actually really good at writing the reports and generating the PowerPoint slides and all of that stuff. The corporations are getting many more reports, longer reports, better written reports, PowerPoint slides, but it doesn't increase their production of widgets at all. And it's because the thing that the AI is doing was not actually helping the corporation in the first place. So you're supercharging operations within your corporation that are of little value. They're all bullshit jobs that just pushing numbers around and that don't actually impact productivity. But that gives you an opportunity to rework your organization. Like when you see that happening, you really should just streamline your organization. But now you have two factors hitting your corporate workforce. One is the AI coming in and taking their jobs, and the other is the AI is telling you what you can streamline and get rid of in the first place. So you're improving operational functions by changing the organization, your organization itself. What I think that we should do as academics is also be looking at what parts of the academic exercise are also non-productive. It's just us doing paper pushing that doesn't really lead to student outcomes. It doesn't lead to new research. It's just paper pushing. So we really have to do a self-reflection as AI moves into our workplace to decide what can be streamlined, what should be taken over by AI, what should we do. So what aspects of college education is non-productive? And AI might be able to tell us as we roll it out and it doesn't do any good. An example, I just want to have one example. Is it really important that we all remember how to do long division? I think I can still do it probably, but I did it for a long time before it occurred to me I don't have to do it anymore. And there's probably many other intellectual exercises that we do right now that are considered very valuable that really are not, or at least they can be done by AI, so they'll be devalued even if they are valuable now. So we have to be looking ahead and say, what's the next long division that's going to drop from being defined as human intelligence? I have to do a quick step back from that. It used to be that people said, we will have AI when it can play chess. If it could beat a grandmaster at chess, we have an artificial intelligence system. And as soon as we started generating systems that could play chess, we said, oh, well, that's not really intelligence. That's a game. And so it's not intelligence, the computer's not intelligent. So you redefine what intelligence is because it's the piece that humans have left. And as AI takes over more and more tasks, we as humans say, well, that's not really intelligence. But eventually we could be backed into a little corner with only a few things that we can do that it cannot. So we have to be careful about our definition of intelligence, or we'll write ourselves right out of the market of intelligence. All right. There is a counter to this. That was sort of the negative side. There's the techno-optimist manifesto, and I give the link there. But it's the idea that technology has advanced humans since the beginning of humans. You know, we learned to use rocks instead of our fingers, and we got bow and arrows to kill animals, and then we learned agriculture. All of those are technological advances, and they led us to where we are now. And therefore, this next technological advance is going to be good, according to the optimists. So there'll be a future of abundance because the AI will be increasing productivity. So there'll be a lot of stuff cheap. We'll be able to cure diseases that we couldn't cure before. We'll be released from drudgery, reduced amount of work we have per week. They've given solutions like universal basic income when all that productivity is there. How, if people don't have jobs, what do we do? And they're saying, well, you just give them money and everybody will have a certain amount of money without having a job. And so then it'll be okay. I disagree with that. In a capitalist society, that redistribution of wealth doesn't come without pain. You know, in the first industrial revolution, there was blood on the streets in Pittsburgh and other areas when the steel mills were being unionized because money was not going to the miners, money was not going to the steel workers. It was all percolating to the robber barons at the time. And it took blood and revolts for that to change. And I'm a little worried the same thing can happen again as the distribution of wealth becomes more extreme and poverty increases for all the people that are unemployed, and there is no basic universal income. I don't know how that would be implemented in this country anyway. That's going to lead to social disruption. And it means us at universities might be at the center. Universities are often in the center of those disruptions. So we could see people protesting not just Gaza, but the work structure of the United States. And maybe we shouldn't have a 40-hour work week. We should have a 20-hour work week, or other radical changes from what we have now. And that'll be different. You know, you have to look at what the United States does, what Europe does, what China does. What impact does it have on the developing world? And all of those are unknowns. It's all going to be a huge disruption. Each of them will probably handle it significantly differently. This disruption will still be there, but how they handle it socially will be very different. And so we just have to keep our eyes out. And I just point at a report where some of those ideas come from. So what should we do in academia? And I start that with a Dr. Strangelove, how I love to stop worrying and love the bomb. This is a bomb. It's going to be a radical change, and there's nothing we can do about it. It's going to land, and we have to adapt to that bomb, and make the best of it. So we have to do things. Some of the things I listed here is we have to teach critical use of AI in all areas, so that our students coming out understand what AI can do and what AI cannot do at the current moment, and what the changes are likely to be in the future. So be critical consumers, not to not use AI, but to be critical consumers of AI. Teach students to live like shark. That just comes out of the manifesto, abundance manifesto. Is you have to eat, and corporations have to eat and change, and if you don't eat and change, you go extinct. So you have to be fast like a shark, consume, and then you survive. It's the only way to do it. So I'd say that can translate into entrepreneurialism. So we have to teach our students that they're going to be in an unstable work environment, and they have to be able to adapt and change as time goes by. Okay, I'm gonna have to go faster. So I list some of the other things we have to do here. We have to have things in the workplace that we can use to increase productivity within academia. So we can use AI as a teacher, AI as a partner when doing tasks. So like GitHub Copilot helps programmers make code faster and things like that. But what I did is I started to write all the points for this, what academia should do. And I came up with a series of points, and it occurred to me that I had to reorganize those points once I wrote them. So you don't have to pay attention to these individuals, but I have 2 slides that were the original points that I came up with and I was going to reorganize. Then it occurred to me what I really needed to do was feed that into AI and have it fix it for me. So I fed those 2 slides into AI, and I asked it, oh, I forgot to include the quote. Oh, I did. I attached a list of measures that college professors can use to adapt to AI in academia, organize that list, and add any missing items to the list. So I just had that bulleted list, and it organized it into these 6 categories, the last category being the missed items. And it was right. It was pretty good. I didn't have them organized so well, but it broke down into those categories. So then it volunteered to produce a graphic. So this is its graphic that it produced with those items, but it's kind of hard to see. So I translated them into individual items, and I'm not going to have time to go into each of them. But if you want to take the slides away and look at some of these, we have access and equitability. We need site licenses for all of this stuff here on campus now so that we can give students access to these materials. And the equity issue is that same study I talked about that was done 2 years ago found that well-to-do students were using the paid-for versions, and not so well-to-do students were using the free versions. And their work is different. So it creates inequity in grading and things like that. So we need to figure out a way to address that. We need computational resources on campus to do these things, and make sure there's training for that to translate our content appropriately. We have to do curriculum modifications, and that might include building large language models from our own content to build chatbots and things like that. And over at Cyberse, they have already done a couple for classes. Integrate AI with other technologies like VR and AR for immersive learning and other approaches with intelligent agents. Allow time for faculty to redesign courses and assignments and evaluation strategies in light of AI. And it's hard work, so we need time to be able to change and get our materials in place. We have to do things like we may have to reintroduce in-person exams, and we may have to rethink doing term papers because AI is really good at writing term papers. It hallucinates in there sometimes, and it used to be bad at doing citations, but they've gotten much better at doing citations now. So we have to figure out other ways to do evaluation, and that includes having human-human collaboration, more integrative processes that we're evaluating along the way, rather than having those final products that could be generated by a generative AI. And we have to be evaluating that thinking process, not those final products. We have academic integrity issues, so we need things that can identify plagiarism. We have to have policies in place about the use or not use of AI in different circumstances, and it's sort of hit and miss individual instructors. In our college, there's like every imaginable use or not use of AI is included in classes. So when students move from one class to another, it's a whole set of different set of rules. And if you move across colleges, it's a whole different set of rules. So there's no uniformity. And some classes haven't considered the issue at all. Okay. We need research and scholarship. We need education research to see what's working and not working, and the impact of, how is AI working or not working. We need more cross-disciplinary collaboration, computer science, education, humanities, and all of that. And then we need administrative and institutional support. So that's time for training, the workshops that are run centrally or by the college to get faculty and GAs up to speed on what's available. And that has to be ongoing because the tools change every year. They're changing at a very high rate. So even if you learn how to use the AI this year, next year it's going to change. So you have to learn it again. Allocate funds for experimentation and testing so that we know what's working and not working. These are just the items that the AI identified that I had missed, and those have all been inserted in that list that we looked at already in the appropriate categories. Okay, so in summary, we can't put the genie back in the bottle. The AI is here. The genie is growing in power in terms of what models are available, its adoption, the financing are all growing. Other people really like the genie, so they don't want it to go away, so we can't avoid it. The genie can destroy society, depending on distribution of wealth and concentration of wealth and all of those issues. But the genie can also produce abundance and freedom from work if we do it right. Oh, that was supposed to, darn, that was the one thing I was going to put in here. I was going to put a picture of the Terminator here. Okay, so that's what I prepared. I hope hopefully I gave you a broad overview of state.
We have time to take a few questions. Is there anything that you want to check the chat? Is there anything there?
I don't have my Zoom window open.
I have a question for you.
Yeah.
So, we are the college of the building architecture and celebration planning real estate scheme was program focused on building. I see you have post-college collaboration such as science, humanities. Is there a way we maybe partner with you, the kind of collaboration with you? No, this is coming. This is really, we want to.
Oh yeah. Yeah, I think we have. There's a lot of opportunity to do that. There's going to be a campus-wide, yet another campus-wide AI coordination set of meetings coming about. And I hope that we can talk about collaboration at that point. The last time we did that, it was held at the dean level. And it was more a territorial thing. It's like, I own AI, this is, no, I own AI. But I think we're beyond that now. And we can get the people in charge of undergraduate education and graduate education together in a room from all the colleges and talk about what can we do. So I think opportunities will be coming up campus wide, but also, college to college, certainly opportunities, I think.
Also, I want to reach out to you.
Yeah.
There's a question there.
Can we say that the original Rosenblatt, the perceptions were hardware while modern ones are software? So I'll talk about that one first. The hardware software boundaries shift all the time. And a lot of times what was software gets hard coded to become faster in hardware. Once it's proven in the software realm that it's a useful architecture. So it's sort of a permeable barrier between this hardware-software distinction. And certainly perceptrons were created with the idea that it was a physical analog to what the human neurons were doing, but it was being simulated in software. But GPUs are very much in that same architecture, and that's why we use them. So it's sort of a hardware implementation, again, but at a vastly greater scale. So yeah, I would just, yeah, you know, I had one slide that I said hardware, and that's going to be as particular operations becomes obvious that particular operations are really needed and being done with software, it's worth encoding some of those in hardware and creating chips that do the same thing, but probably 1,000 times faster than if you do it in a general processing computing environment. So your description of AI hallucinations sounds eerily similar to the hallucination beliefs systems of humans. Yeah, yeah, it does. And I think that's why people chose that word hallucination to describe these. But what's going on is very different from the way that humans, when humans hallucinate and when the AI is hallucinating, the underlying systems, I think, are very distinct. So the analogy only goes so far, but it does look the same.
How does it correct the error?
Which kind of error?
Putting in bad information, wrong information, how does it correct the error?
One of the things people are doing is trying to clean the data. So they're right now at Amazon and Google and many of those corporations, what they're doing is hiring subcontractors, thousands and thousands of them, that are culling through the input data and trying to clean it. And also running the systems, the humans running the systems, and seeing where the errors are, and then trying to either putting a filter in or fine tuning to try to get the mistakes to go away. Yeah, but we don't really know which nodes are wrong. We can't really fix it. So that we're trying to fix the input data and we're trying to filter the mistakes at the end. But I think that's where some of the active research is happening. They're changing the architectures. I was on a project, one of those projects I listed was included a subgroup at Rice that were looking at the neural networks we had produced and trying to figure out what nodes are actually doing the real work, and can we abstract that away? And so can we understand what the neural networks, how it's getting to the conclusion? So there's active work going on in that area. And if we start to learn how that's working, then maybe we can get fixes and actually go in and do brain surgery on the.
So you can bisect that at some point and say, this is where the errors are for.
Yeah. Right. Hopefully. So that you can use visualization techniques and other things. It's really an unsolved issue right now. It's active research. Okay.
Thank you for coming. Yes, thank you.
Thank you. Sorry for the late start.
Yes, sorry about that.
That's okay.
Yes, okay, thank you. Okay, so we're gonna finish our lecture here. Thank you guys for logging in, and sorry about the inconvenience with the technology. This will be recorded and will be available for everyone. Thank you, bye-bye.